Hello, we are here at the assistant nursing class, and one of their open fridges that they store their supplies in has a problem. Go ahead, Raul.
Well, I think it's a charge problem, so what I did was I hooked my gauges, and I still have to bleed it, so I'm going to bleed it, or purge it. And I'm also going to do the same thing on the low side. Now let's see if we see anything strange here. We got 0 psi on the low side, and we have 105 psi on the high side. Notice that we do not have the temperature 134.8 on these gauges. So
in other words, those gauges are not for 134.8, they're for everything else that's on there. So how do we determine the pressure temperature relationship?
There's two ways. You can get a paper PT chart and find it, or I like using my downfalls app. Which I just select the refrigerant that it is, and it's 134A. And then we just type in the pressure. And we hit done. The evaporator right now says that the saturation is -15. If that was true, it should be freezing cold in that box. Right now the box is around 80 degrees, so that tells me that it's probably low on gas. Now, just do the same thing with the high side. Actually, let me back up, so I didn't explain. How do I know that -15 degree is low? Okay, first we need to know what type of system are we dealing with. There's 3 different types. AC, which is high temp, mid temp, which is a cooler, and low temp, which is a freezer. Since I know this is a cooler, the evaporator temperature, and this is a rule of thumb number, is supposed to be a 25 degree evaporator, which gives you a box temperature of 35. Right now, it says that the evaporator is -15. So the pressure should be, and this is what I like this app also for, it can tell me what it needs to be. It needs to be like 22 or 20 to 22 psi. We way below those specs. Now, how do I know if the high side of the system is in specs or not? First of all, we need to review what is the job of the condensing coil. To reject heat. And how does it reject heat? For it to reject heat, it has to be hotter than the surrounding ambient temperature. How hotter? For coolers, it should be 15 to 20 degrees above ambient temperature. So, I really don't know what the temperature inside here is.
I'll check on my
We need to check.
thermometer right here, and that'll give us a good outlook.
It's not looking good though.
No, it's not.
So meanwhile Oscar's doing that, I'm going to show you what a 100 saturation temperature, PSID, I'm sorry, is in saturation temperature. It's 87.7 degrees. So now we're going to subtract that from the number that Oscar gets on his thermometer.
I'm looking at 84 so far, 84.
So basically a 3-degree difference. That condenser cannot reject heat because it's not 15 to 20 degrees above the ambient temperature. So what do we have to do? We have to charge the system with more refrigerant. Now, there is another bit of information we need. What type of metering device am I dealing with here? I don't know if the camera can pick this up. You see this small tube right here? That is a cap tube system, meaning it's a fixed orifice system. And you might say, well, why is that important? Can I just grab the refrigerant jug and start adding gas? No, because there's two methods that we use in the field to charge a unit: superheat and subcool. If you have a TXV system, which we're going to describe in a later date what that looks like, you need to use subcooling. But since this is a fixed orifice, you should charge the system with this superheat method. And just to recap, what is the superheat method and what am I checking by that? The superheat method checks how efficient is the evaporator evaporating the refrigerant. So basically, liquid refrigerant comes into the evaporator, and as it passes through the evaporator, the heat that absorbs in the evaporator, it should change it back into a vapor.
Still holding. So looks like we're gonna get 78, 77.
Yeah, we have 87 on here with this saturation temperature.
Yeah.
It's very low.
All right.
So now, what we have to do is, with that same thermometer, we have to determine which line is the suction line. How do we determine that? Okay, there's going to be two lines on the compressor. A small line and the big line. The small line, if you accidentally touch it, it can burn you. This is the discharge. This is highly superheated vapor. If you touch this one, this is the suction line. This is where you have to put your thermometer at to check superheat. Let me grab the thermometer, Oscar. You don't have to move. So keep in mind the thermometer has to be insulated from the surrounding air. So what I do is I put it underneath the armor flex. Where's the light on this? I'm going to leave it for a few minutes until it stops when it stabilizes. I expect it to be hotter than that. But then again, it still has negative 15. That's a lot of superheat. Negative 15 saturation temperature minus whatever that is. Look at that, is restricted. Doesn't feel restricted. So 50 minus negative 15. What would you say that is, Oscar? More than 30 degrees of superheat?
Definitely close to 40, plus you have to close the suction line up here too.
Yeah. So what we're gonna do is gonna start adding gas and see if we can get it to work better.
Without even looking at the saturation chart, we can tell it's
slow in refrigerant by the subcool superheat temperatures that we see over here. Superheat is letting us know that we checked already the coil. There's nothing blocking the coil, and it's pretty clean, as you can see in there. And even inside the unit, it's fine. There's a few items, not enough to block the intake of the evaporator coil.
And we physically touch the evaporator too, the
Yeah.
ice on it.
Okay.
So what we're gonna do is gonna use our gauge manifold, and always remember this because I forget sometimes. Don't unloosen the straight piece. Always loosen the 45-degree angle, and you're gonna connect it to your tank.